Hello everyone, welcome back to my channel. Today we will be solving Leetcode problem 1007, minimum domino rotations for equal row. Okay. In a row of dominoes, tops of I and bottoms of I represents the top and bottom halves of the ith domino. A domino is a tile with the numbers from 1 to 6 on each half of the tile. Okay. We may rotate the ith domino so that the top and the bottom swap values. Okay, return the minimum number of rotations so that the values in the top are same or the values in the bottom are same. Okay, if it cannot be done, then return -1. Okay, so let's take this example. You see, this is the top of the domino, this is the bottom of the domino. Okay, the idea is to make all the top dominoes equal or the bottom dominoes equal. Okay, let's say we have swapped the second domino. Okay, here let's say we have swapped these two values. Okay, so one has come down and two has come on the top. Okay, the same way we have also swapped these two. Okay, so as a result, if you see, the top contains all the values as 2. Okay, here the minimum number of swaps required is 2. Okay, so we have swapped this and this particular domino. Okay, and let's say we want to make all the bottoms as 2. Okay, in that case we will be swapping this with this, so the bottom will be 2, and since it is already 2, we don't have to swap this domino. Bottom is not 2, that means our intention is to make the bottom as 2, so we will swap it. Okay, we'll only swap it if any one of this value, like if the opposite, the idea is to make the bottom as 2, right? If the top has 2, then only we'll swap it. If the bottom is already 2, then we don't have to swap it. Okay, here we have a value which is not equal to 2, but the top has 2. That means we can make this domino by swapping it, right? So we'll swap it and this will become 2. Okay, so the total number of swaps we have done is 1, 2 and 3. Okay, so if we want to make all the bottom as 2, that it requires 3 swaps. If you want to make all the tops as 2, then it will require 2 swaps, right? So the idea, but the problem statement says we have to return the minimum number of swaps. Okay, so the minimum number of swaps will be 2 in this case. If you make all the top of the domino as 2, then we only require to make 2 swaps. Okay, so here we have tried to make all the dominoes top of a domino as 2. Okay, but ideally not necessarily this will lead us to a solution. Okay, idea is to make all the top dominoes or the bottom dominoes as equal. Either it can be 1, it can be 2, it can be 3, it can be 4, or it can be 5, or it can be 6, right? We have to check which of these possibilities will actually lead us to the minimum solution. Okay, so yeah, let's try to code it down. Okay, so yeah, let's have a function which will tell me the minimum number of swaps required to make all the dominoes equal to a particular value, either the top or bottom. Okay, let's say it will tell minimum swaps. Let's say minimum swaps which will take tops and bottom, and it will take a value. Okay, the idea is this function will basically return, okay, minimum swaps required to make either top all tops equal to value or all bottoms equal to value. Okay, and if we try to make all tops equal to the value, there will be some swaps required, and in the similar case, if we want to make all the bottoms equal to a particular value, there also it will have a minimum number of swaps, right? Among those two possible swaps, it will always return the minimum swaps required. Okay, so let's have a variable called length which will have the length of the array. Okay, as I mentioned, we want to count the minimum number of swaps. Okay, let's say we have a variable called swaps. Okay, so let's try to iterate through the arrays and see our intention is to make all the tops or all the bottoms equal to this particular value. Okay, when can this be achievable? Let's only consider at a particular index. Okay, if the value at a particular index, if it is already equal to the desired value, okay, let's say we want to make the top as 2. If the value at this particular index is already 2, that means I don't have to do a swap. Okay, or else if the value at the bottom, let's say the top is not equal to 2 but the bottom is 2. Okay, in this case if I swap it, then I can make the top as 2. Okay, in this case I require one swap. Okay, if any of these two dominoes does not have the desired value, that means there is no way I can actually reach out to this particular value by doing swaps. Okay, let's say this is 3 and this is 5. No matter how many times I swap, there is no way I can make the top as equal to 2, and there is no way the bottom can reach to 2, right? So if tops of I, if it is not equal to value, and bottoms of I, if it is not equal to the value which we want to achieve, that means there is no way I can make them as the desired value. In that case, we will be returning the maximum integer value, saying that it can't be achievable. Okay, whenever we receive this, that means it can't be achievable, right? Okay, and the other case, okay, now if you want to make all the tops as equal to 2, in that case there will be some number of swaps. Okay, let's have it as top swaps. Okay, top swaps is a variable which will tell me the minimum number of swaps required to make all the top of a domino equal to the desired value. Okay, so if tops of I, if it is not equal to value, okay, so we will only reach at this particular point if any one of this particular value is actually equal to the desired value. Okay, if bottom of I or if tops of I, if any one of these or both of them are, if they are equal to the value, that means we'll be reaching at this particular statement. Okay, in this case, if tops of I, if it is not equal to the value, then I will be basically incrementing the top swaps. Okay, in the same way, if bottoms of I, if it is not equal to the desired value, then I will basically increase the bottom swap value. Okay, let's have the bottom swaps equal to 0. Okay, the moment I came out of this loop, then we'll be having both the minimum number of swaps required to make all the top as equal to the desired value, and the minimum number of swaps required to make all the bottoms as equal to the desired value. Now I have to return the minimum of both these. Okay, bottom swaps and top swaps. Okay, now that I have my utility function ready, let's have a variable called least swaps is equal to integer.max value, saying that if we are not able to achieve any of this particular combination, then we'll be basically returning the -1, right? So idea is to make all the dominoes top as 1 or bottom as 1. So what are possible values? We can actually go from 1 to 6, right? The value will start from 1 and go all the way up to 6. Okay, and we'll increment it one by one, and then we'll try to calculate the least swaps as the minimum of the current value, which is the least swaps, and we'll also call this particular function min swaps, where we pass top, bottoms, and the current value. So this will basically tell me we are trying to convert all the dominoes top or bottom to this particular value. And then so if least swaps, if it is equal to integer.max value, that means it can't be achievable, right? We cannot make all the dominoes equal. In that case, we have to return 1, right, as I mentioned, or else we will simply return the least swaps required, right? Yep. So let's try to run this program and see. Yeah, it has satisfied the basic test cases. Let's try to submit the solution. It has also satisfied all the test cases, okay, and it has done pretty well, okay, as you can see. So let's also try to analyze the time complexity over here, okay. Let's try to break down the time complexity. So here if you see, we are actually running this loop, okay. So running this loop, right, so it will be order of n, where n is the length of the tops or bottoms, okay. So this, the overall time complexity here will be order of n, and here we are running this particular function from value 1 to 6. So we are actually running it 6 times, okay. So it's always fixed, okay. So there is no increase in the time complexity over there. So overall it will be the order of n, right? Yeah, that is the overall time complexity. And what about the space complexity? Yeah, we are not using any extra space, like we are just using some basic variables, okay. Apart from that, we are not using any extra space like arrays or something like that. So that space complexity is constant space. Yeah, that's all about this problem. Do subscribe to my channel for more such coding videos. Thank you.